All right, so now that you've watched a quick tutorial on how to use Desmos to help you graph all types of equations, we're going to use it today to learn about different types of linear equations. And again, we're going to use Desmos to help us check our answers in graphing these. So again, a linear equation is an equation that when it is graphed can be represented by a straight line. So we've talked about that a lot, and all of these are linear equations. So if you do them correctly, they should all look like straight lines. If you get a curved line, if you get a circle, if you get anything other than a straight line, you have done something wrong, or it is not a linear equation. So there are three different forms. And again, you don't need to write this down. We don't have to memorize this by any means, but we're going to talk about all these different forms and what they look like when we use Desmos. And all of these will give us linear equations. So we've already talked about slope-intercept form. That's y equals mx plus b. And again, it's called slope-intercept because all you need to write it is the slope and your y-intercept, hence the name slope-intercept form. We also have point-slope form. And yes, you can guess it. You would need a point and the slope to create the equation. So the point would be x1, y1, and your slope would be m. Then you have standard form, ax plus by plus c equals 0. So the first one we're going to look at, again, using Desmos. If you get your website up and you put it open next to what we're doing here, you can go back and forth and check your work really easily, or you can graph it and then use that graph to help you the graph in our Google Slides. So if we look at the first one, again, I'm going to have to make it smaller. It is y equals 3x plus 2. So go ahead and tell me in the chat, what is the y-intercept of this line? Again, what is our b value or the y-intercept? Yep, 2. So I will put my first dot right at 2, just like we've been doing. Again, we've talked about graphing these before, so I'm going to move a little quicker than normal. And then our slope here is 3, or 3 over 1. So from 2, I'm going to go up 3 over 1 and put my second dot. And if I do that, my line should look something like this. Doesn't need much to change it. So there's my line of y equals 3x plus 2. I've done that just on my own. Now, if we pull up Desmos and check it, the line of y equals 3x plus 2, those look quite similar. Again, Desmos might give you a bigger graph than we have, or it might look a little different. So that's why you got to make sure you're checking your work and you're putting your points in correctly. Then if we go to the next one, y equals negative 2/3 x plus 4. So same thing, we know that 4 is my y-intercept. So that means now I need my slope, which is negative 2/3. So I'm going to go down 2 over 3, put my next dot. And then if I connect those like normal with a line, it should look like this. And again, just thinking about this, this is one of the things that I think people were finding confusing. If I just think about this, it has a negative slope. So that means the line should decrease, or from left to right go downwards. This line is doing that already, so it looks like we've done it correctly. So let's check it in Desmos. So if you go to Desmos and you punch in y equals negative 2/3 x plus 4, you might get something that looks like this. This is not a linear line. And if you look closely at what we did here, let me blow it up so you can see. The x shouldn't go on the bottom of your fraction. It is negative 2/3 times x, or the x should be next to the 2/3 plus 4. So if you did this, you're going to get a crazy looking graph because our variable is in the bottom of a fraction. That's not what we want. Again, we did it already. We know it should be linear. So it should look like this. Again, make sure that x is not on the denominator of your fraction, or it's going to give you a different graph that is non-linear. So again, if we go back and check this one out, it looks just like what we got, right? We got a decreasing graph that looks very similar. So that is perfect for that one. Now is where we're going to touch on some other ones, right? So if we look at this one, we're going to punch it into Desmos. Desmos will graph it for us, and we can use this graph to graph it ourselves now. So I'm going to blow this up and let's look at what our x and y intercepts are here. So we have 4 as our y-intercept and 6 as our x-intercept. So 4 is our y, 6 is our x. So let's go ahead and put dots on those here. So 4 is our y-intercept, 6 is our x-intercept, and then we can put our graph here, our line, to connect them. Super easy, right? That's even easier than having to memorize the slope, the intercepts, in this case, plot the point and then do the slope. So let's check it out. Does that look like what we got here? Yeah, they look super similar to me. So that is an easy way to, again, make sure we graph it properly. And again, the key there, though, was making sure the points were still exactly correct like they are on the line. You can't just throw the line on what it looks like. It still needs to be very, very accurate, if not perfect. So let's try one more. All right, 2x plus 3y equals 12. That is a good one. So if I punch it in here, again, I'll zoom in so everyone can see it closely. Let's check our y and x intercept, 4 and 6. All right, 4 and 6 are our x and y intercept. So I am going to put these there here. So boom, boom. This looks real similar to that first one we did, doesn't it? And then let's connect them. And let's check and make sure it looks pretty accurate, right? So there's that one. Yeah, they look almost identical. Gotta make sure that touches right up here. There we go. Perfect. Yeah, looks just like it. All right, so now if we think about those last 3 we did, right? So that one looked like that. That one looked like, these all look, they're in different forms, but they're all the same. So if we put them all in the same thing, look what happens. Only one shows up. You know why that is? Because they are all actually the same line. Even though they look like they're totally different equations, those are all the same exact line in different forms. So you can have something that looks totally different, but it might be the same line. It touches everywhere. It's the same thing. So here's what you're going to do. Use Desmos to help you graph the next couple graphs. So I'm going to split you in your breakout rooms, and then you're going to use Desmos. Make sure you'd select exactly where the x and y intercept are, or pick exact points where you put your 2 points here, and then you're going to connect it with your line. So go ahead and get started. I'm going to open the breakout rooms, and I'll be around to help. Make sure you flag me if you're confused.